Assalamualaikum warahmatullahi wabarakatuh. Best greetings to all of us. Hello happy students wherever you are. Magnetism is something that cannot be separated from the life of humans. Earth itself is the largest magnet that can provide great benefits to humans. Earth's magnetism allows humans to use a compass as a guide. Animals also take advantage of the Earth's magnetic force as a guide for migration. Subsequent technological development, inspired by the principle of the Earth magnetism, result in various applications of magnetism in the field of technology. This helps a lot of human activities with various tools that are useful for life. Therefore, we are from Group 3, Ahmatul Umri Hasibuan, Friska Pakpahan, and Ulina M.S Simangunsong will present a learning video about the concept of magnetic field, electromagnetic induction, and the use of electromagnetics in technology product as our final project for the Basic Science and Laboratory Activities course with the lectures Mam Lastama Sinaga, Magister of Education. Magnet comes from the Greek, namely magnetis lithos, which means magnesian stone. In Greece, there is an area that contains a magnetic stone called magnesia, or currently known as Manisa. Magnetism is a property of matter that is observed or seen as a force of attraction or repulsion between like or dissimilar poles. There are two magnetic poles, namely the North Pole and the South Pole. Magnetic field is the space or area around a magnet that's still affected by the magnetic force. The drawing of magnetic lines of force shows the magnetic properties of an object. Namely, magnetic lines of force never intersect. The closer the magnetic lines of force in a place, the stronger the magnetic field at that place. The number of lines of force or magnetic flux coming out of the North Pole of a magnet is always the same as the number of lines of force entering the South Pole. The farther away from the magnetic poles, the weaker the magnetic field of the object. Magnet can be divided into three types based on the materials. First is ferromagnetic materials that can be attracted by a strong magnet, like iron, steel, cobalt, and nickel. Second is paramagnetic materials that are weakly attracted by magnets, like aluminum, manganese, and platinum. And last is diamagnetic materials that cannot be attracted by a magnet, like bismuth, gold, copper, zinc, and silver. Magnets are also divided into two types, namely temporary magnets, that is the material that can be easily made into magnets, but these materials easily lose their magnetism. Next is permanent magnets, that is the material that are difficult to remove magnetism. The magnitude of the magnetic field at the point is affected by the magnitude of the magnetic force experienced by the point, inversely proportional to the distance of the point from the magnetic source. Electromagnetic induction is a symptom of the occurrence of an electric current in a conductor due to a change in the magnetic field around the conducting wire. Michael Faraday was the scientist who discovered this phenomenon in 1831, and James Clerk Maxwell was the scientist who described it mathematically as Faraday's law of induction. Faraday concluded, although a fixed magnetic field does not produce an electric current, but a changing magnetic field can produce an electric current. The electric current produced by a changing magnetic field is called an induced current. The process of generating an electric current due to a changing magnetic field is called electromagnetic induction. Magnetic flux is the change in magnetic field. The magnetic flux is produced by multiplying the magnetic field by the area of the field, which are perpendicular to each other. You can see the equation in your screen. If it is not perpendicular but forms an angle, then the magnitude of the magnetic flux is multiplied by the cosine of the angle. You can see the equation in your screen. Faraday's law states that if the amount of magnetic flux entering a coil changes, then the electromotive force will occur at the ends of the coil. You can see the equation in your screen. Lenz's law states the induced current will appear in such a direction that direction of the induction opposes the resulting change. The minus sign in the Faraday equation above shows that the epsilon form has a direction opposite to the magnetic flux. Henry's law states that if the electric current flowing in a conductor changes with time, then in the conductor there will be a self-induced. You can see the equation in your screen. And change in current 1 ampere every 1 second, you can see the equation in your screen. When the electric buzzer button is pressed, the current circuit is closed and current flows in the coil. The flow of electric current in this coil causes the iron in it become an electromagnet that is able to move the batting arm to hit the ball, so it sounds. The working principle of the telephone is to convert electrical energy into sound energy. When there is a conversation, electrical energy flows into the telephone wire, causing an electromagnetic effect whose strength varies so that it can vibrate the flexible metal diaphragm on the telephone speaker. The vibration of the speaker is what ultimately vibrates the air around it and gives a hearing effect to our ears. Magnetically levitating or flying carrier. This train is flown approximately 10 mm above the rails. However, this train can go up to 650 km per hour, and it will be neither fall nor derail. This is because the maglev train applies the principle of magnetic repulsion and is driven by an induction motor. Maglev trains have become a means of mass transportation in several developed countries such as Japan, USA, China, and several European countries such as France, Germany, and London. In general, MRI or magnetic resonance imaging is used before surgery on the patient's body. The way the MRI detects disease is by placing the patient in a magnetic field that has a strength 500 times stronger than the Earth's magnetic field. A magnetic field of this magnitude can cause the body's nucleons to rotate and line up parallel to form a needle that resembles a compass. Then, the nucleon is then soldered with radio waves to induce its reduction. When they are aligned, the nucleons will emit waves which are finally retrieved by the computer as an imaging of condition in the body. Enough for our discussion of the magnetic field on this occasion. Hopefully, with this video, the audience and viewers can understand the magnetic field much better. Don't forget to like, subscribe, comment, and share this video. Keep happy and healthy. Wassalamualaikum warahmatullahi wabarakatuh. Best greeting to all of us.